Hello everyone, welcome back. Today we're going to be looking at the insurance side bet that Spitznagel mentions in Safe Haven. This is the one where you are putting aside 91% for the dice roll and you're saving 9% for the insurance side bet. So the question that I had was, how does he calculate the geometric average to be 2.1%? Because I, for one, cannot calculate 2.1%. I don't get it. And then on top of that, when I code this in Python, I never get 2.1%. So we'll do the Python stuff in another video. In this video, we'll try and get at this mathematically first. So just to go over the bet as I understand it, you're playing with Nietzsche's demon. You have all of your wealth on the table in front of you, and if you roll a 1, he's going to take away 50%. If you roll a 2, 3, 4, or 5, it's going to give you 5%. If you roll a 6, he'll give you 50%. Now, this is a special game that you can play. This is the insurance one. And what the insurance side bet I take the insurance side bet to mean is that after every roll, what you can do is, instead of betting 100% of your net worth on each roll, what you can do instead is only bet 91%. Let's draw that better. You can bet only 91% of your wealth on the bet, and then this remaining 9% you save as an investment not as an investment, you save as insurance money. And the way that the insurance works is this. If you roll a 2, 3, 4, 5, or a 6, then that insurance payment of 9% goes away. You just lose it. But if you roll a 1, then that insurance payment of 9%, whatever the 9% may be, is quintupled. And I understand quintupled, or going up by 500%, to be calculated by multiplying the number by 5. So let me give you an example. Let's say that you were starting out with a starting wealth of $1. First, it doesn't matter what the roll is. The first thing that you're going to do is separate that into 91%, which would be 91 cents, and then 9%, which is 9 cents. Regardless of what the roll is, you will always be separating it into these two things. And now Nietzsche's demon rolls the dice, you get a 1. So what happens is you take the 91% and that's the money that you're betting. So you're going to take the 0.91. You're going to multiply it by 0.5 because Nietzsche will be taking away 50% of the 91% because you rolled a 1. And so if you do that, what you get is 0.455. So you have 45 cents when you roll a 1, and that's what happens to your bet of 9% or 91%. But let's look over here. This is the insurance side bet that you're making, and when you roll a 1 and you've paid for insurance, then what happens is you increase that 5-fold. So you take 0.09, you multiply that by 5, and you get 0.45. So that's what happens to your insurance side bet when you roll a 1. So you add those two together, you get 0.905, and that would be your ending wealth when you roll a 1 and you start out with an original wealth of $1. You end up with $0.90.5. Okay, so that's what I understand the insurance side bet to be. Before Nietzsche's demon even rolls his dice, what you do is you take 91% of your wealth and you set it aside for the bet, and you take 9% of your wealth and you set it aside for insurance. and then you add the two together, and that'll give you your end wealth after you've rolled the bet. Okay, that's what happens when you roll a 1. Now let's go over what happens when you roll a 2, 3, 4, or a 5. So I'm gonna save the 1 part because we'll come back to it later. Let's do this. There we go. Okay, so if you were to roll a 2, 3, or 4, or 5, once again, you have your original wealth of $1, but and you still are going to take 91% of that and gamble it away. You're going to take 9% of that and put it to insurance. So that once again looks like 0.91 and 0.9. And if you roll a 2, 3, 4, 5, then what happens to the 0.91 is that it's multiplied by 1.05 because it is being increased by 5% by Nietzsche's demon. So let's do that. 0.91 multiplied by 1.05 is 0.9555. Let me write that a bit more clearly. There we go. Now, when you roll a 2, 3, 4, 5, you don't get anything from the insurance premium. It just takes your money away because that's how much the insurance costs. So what ends up happening is you do 0.9 multiplied by 0 because it's a price and it takes it away. So that's equal to 0. Then you add the payouts, which is equal to 0.9555. So that's the end result if you were to roll a 2, 3, 4, or a 5. If you were to roll a 6, let's do that. Let's see what that happens. Once again, before you even roll, you're taking your wealth, you're taking 91% of it, and you're setting that for the bet that you're going to do with Nietzsche's demon. You're taking 9%, the remaining 9%, and you're setting that aside for insurance. So $1, 91 cents, 9 cents. Because you're rolling a 6, you don't get an insurance payout, so you're basically multiplying the 9 cents by 0, which is equal to 0. So you've just lost that 9%. Because you've rolled a 6, Nietzsche's demon is going to give you 50% of this 91 cents. So you multiply that by 1.5. 0.91 multiplied by 1.5 is equal to 1.365. You add those two together and you get an end wealth of 1.365. Okay, so what you see here is that if you roll a 1, you'll get an end wealth of 0.905. If you roll a 2, 3, 4, 5, you get 0.9555. And if you roll a 6, you'll get 1.365 at the end. Now, to go back to the question that I had, it was, how on earth did he calculate a geometric average of 2.1%? Okay, so I'm going to try and calculate it the way that I calculated the 40-60 split in the last video, and we'll see what happens. So let me just write down first what these payouts are so I don't forget them. So this is for a 6, 1.365. So 1.365, and a 1, 2, 3, 4. That looked so ugly, wow. Is 0.9555, and this one is 0.905. Okay, so the way that we did the 40-60 split was very similar. First, we calculated what would happen to $1, and then we raised each of the sides to the power of 50, and then we found the geometric average of that. So we'll do the same thing for these ones, because in theory it should work. So if you take 0.905 and then raise that to the power of 50, and then you multiply that by 0.9555, raise that to the power of 50, and then 0.9555, raise that to the power of 50, 1, 2, 0.9555, raise that to the power of 50, 0.9555, raise that to the power of 50, 1, 2, 3, 4, and then 1.365, raise that to the power of 50, and then you raise the entire equation to the power of 1 over 300. You will get your geometric average, apparently. So let's try that out. Already forgot the numbers. 0.905. 0.905 raised to the power of 50, multiplied by 0.9555, raised to the power of 50. And I know that I'm pretty sure I'm able to multiply 0.955 or raise it to the power of 200, but I'm going to be extra precautious and not do that. And raise that to the power of 50, multiplied by 0.9555, raised to the power of 50. 1, 2, 3, 0.9555, raised to the power of 50. I missed something here. So that's 1, 2, 3. How many have I done? Yeah, so I've done 1, 2, 3, 4. Multiplied by 1.365. 1.365 raised to the power of 50. You get 4.31717. Raised to the power of 1 over 300. And that is equal to 1.00488. So we'll round that up, or 0.489%. So that is our geometric average. Now, 0.489% is definitely not 2.1%. And that is my, or even 3.6%. But more precisely, 2.1%. And that is my big issue. I don't understand where I am going wrong in my math to not get 2.1%. So if you have a solution, or if you spotted a flaw in my math for why I'm not calculating it correctly, please leave a comment below, or leave a comment with a link to your own video where you go through the math, and I will be eternally grateful to you if you help fix the math. Thanks for watching.